In this video, we will do some more examples from section 3.4 on combining functions. So this example says, let's let f of x be the square root of negative x and g of x equals x squared minus 4. We want to evaluate each expression, find its domain, and then sketch the curve. So part A, we have this composition of functions. This is f of g of x. So that means the outer function is f, and we're going to plug in g of x into it. So g of x is x squared minus 4. And now whatever's in the parentheses, in this case it's x squared minus 4, I got to plug that into my f of x function where the x is. Okay, so doing that, we get square root of negative, and then I'll put a parentheses where the x used to be, because now I got to plug in x squared minus 4 there. So parentheses x squared minus 4. And that parentheses is important, otherwise I may forget to distribute this negative sign to each of these terms. Okay, so let's simplify that. Let's distribute it. And if I distribute it, let me write the 4 first. That'll become positive, and I'll get 4. And then I'll write the x squared. I'll get negative x squared. Okay, so my expression simplifies to this, square root of 4 minus x squared. Okay, so I need to think about domain as well as what this curve is going to look like. So I'm going to set up some axes. Eventually I'll need to sketch this. So pause the video for about 30 seconds. See if you can identify what of our common graphs does this look like. 4, 3, 2, 1. Pause it for 30 seconds. See if you can identify which common graph this looks like. All right, so hopefully you did that. Hopefully paused it and tried that for about 30 seconds. Okay, so if we weren't sure, what we could say is, well, let's let y be equal to this thing, square root of 4 minus x squared. And then I'll get rid of the square root. So squaring, I get y squared equals 4 minus x squared. And if I move x squared over, we get x squared plus y squared equals 4. And now hopefully we see, well, this is looking like the equation of a circle. This is a circle. And this 4, well, this represents the radius squared. Okay, so we've actually seen this basic graph before in class when we sort of go backwards from a circle. But the thing is, if I go backwards from this step and I square rooted both sides, you know, technically I'd get a plus or minus showing up. I'd get a plus or minus if I were to square root both sides. And if I have the positive root, well, then my y values, these y values, well, these are all going to be non-negative, which means the graph is just the part of the circle with non-negative y values. It's the top half. Okay, and then I know the center, I know the radius is 2. So this point right here is 2, 0. This is going to be 0, 2. This will be negative 2, 0. That is our semicircle, our upper semicircle. And then having the picture, now it's easy to write the domain. The domain of this goes from negative 2 to 2. Brackets on both because those x values are included. Okay, so this is my graph. I got the domain. It also wanted me to evaluate the expression, which was this. Okay, so let's do another example. Part B now wants me to do it in the other order. Okay, so I want you to first pause the video and try this on your own. So pause it for about 3 minutes to try this on your own. 4, 3, 2, 1. Pause it and try this on your own for about 3 minutes. All right, so hopefully you did that. Hopefully you paused it and tried it. Let's talk about it. So now I have g of f of x, and f of x is the square root of negative x. So I got to take this thing in parentheses, all of this, and plug it into g, where the x is. So that'll give me, instead of x squared minus 4, I'm going to be plugging in this square root of negative x in where that x normally would be, this x right here. All right, and now let's simplify this. Okay, so I square that square root, as we saw in one of our examples from last time. Well, they'll cancel, and we'll get negative x. I still got that minus 4. But I got to be careful, and I got to think about my domain. And for this domain, I got to think about, let's think about our restrictions. Let's think about our restrictions. Okay. And I see one restriction here. looking back at my original, and it's important that I look back at the original because in the simplified form, well, the square root, and the square root gives me a restriction, has disappeared. Okay, so I got to look back to the original to see were there any restrictions there. Okay, and there are. The thing that's inside the root, which is negative x, that's got to be greater than or equal to 0. So if I divide both sides by the -1, I'll get x. It'll flip the inequality, and then 0 divided by -1 is 0. Okay, so my domain is x is less than or equal to 0. In fact, I'm going to tack that on at the end of my answer here. X is less than or equal to 0. So this expression actually evaluated to negative x minus 4, but with this restriction that x is less than or equal to 0. Okay, so now I need to sketch the graph. So let's sketch this thing first without the restriction, just y equals negative x minus 4. And then I'll sketch it with the restriction, y equals negative x minus 4, but with the condition that x is less than or equal to 0. All right, so let me draw some axes for this first one, some axes for the second one. So the graph of negative x minus 4, well, this has a y-intercept of negative 4. In fact, let me just write the whole coordinate of it. It would be 0, negative 4. All right, and the slope is -1, so it's going like this. Okay, just by symmetry of this picture, thinking about the slope, well, the x-intercept has to be at -4, 0. Okay, so, well, how is it going to change now with this restriction? Well, that restriction is saying, just take the part of the graph where the x values are less than or equal to 0. So that is just going to be taking, this is where x is 0, these are where the x values are less than or equal to 0. It's just going to be taking that part of the graph. So if I draw that in, just that part of the graph, I get something like this. This is 0, -4. The x-intercept is -4, 0. And that's my graph of this function. Let's just write the domain. Domain goes from -infinity, parentheses, to 0. 0 is included, so bracket. Okay, so that is my graph. All right, and that is my answer.